Welcome to the session on DDD and REST, while still a couple of folks coming in. My name is Oliver Gierke. I work for Pivotal, the company that's hosting that conference here. I'm the Spring Data project lead, so working with a couple of other Spring engineers on data access related topics. But I have a bit of a history in consulting for Spring Source back in the days and helping a lot of customers to build, for example, RESTful APIs. And that basically led to me getting in touch with REST concepts and the Spring Data side of things, especially the repositories with the DDD concepts. And it turns out that like basically a triangle of projects from that area has some, or made up some connection, some interesting. As I said, the first thing, the Spring Data repositories, and the fact that like the entities that you deal with in your application sort of forming aggregates by the virtue of the fact that you have a repository for them. The other part that played into that is that from those consulting gigs where we built RESTful APIs with customers, we extracted a library called SpringHadios not for Hate Oracle Application Server, but hypermedia as the engine of application state. It's basically a library that you would use at like Apache Commons or something in your Spring MVC application, and it makes it easier to add hypermedia elements to your JSON representations. We'll go into that in a bit later on. And bringing those two things together, like around about 2 or 3 years ago, we started to think, okay, there are these repositories and these aggregates, and we have this library that deals with hypermedia aspects of REST. Can we bring them together and actually build a framework that makes it easier or covers certain patterns, implements certain patterns, REST patterns, on top of these libraries? That's what Spring Data REST basically is, and I'll be going to talk about that in detail and cover the advanced part of the library in a talk on Thursday. But I bring that up here because building that library, that Spring Data REST library, made us think about, okay, what's the best way to, let's say, set up resources for a certain domain model, right? So while the casual reader might just think, okay, we're just exposing data via REST, which we sort of do, but actually then again not do. All that development basically let me think about, okay, what is it, what we're actually doing here? How do these domain-driven design concepts translate into the RESTful world, and what can we maybe learn from the domain-driven design idea in terms of writing RESTful APIs? And the talk basically is a summary of exactly that, right? So the question that I would like to answer in this talk is, it's basically 2 questions. The first one is, when we're designing RESTful APIs, what can we learn from DDD? Which concepts can we actually transfer? Which concepts can we maybe not transfer? And some ideas I'd like to give you in the next like 50 to 60 minutes. And by that, also looking at, like, let's say you have an existing application and you have your domain classes, your entities, your aggregates in there. What is a good way to actually build, or how do you actually build a good RESTful API on top of it? Is the easy way make a resource for every entity? Is that really a good way? What consequences does that approach have? And is there maybe a better one, right? All right. So to get the elephant out of the room, who has read the book till the very end? Ah, sheesh, that's only 10% of the people who originally raised their hands. There's an alternative to the book that I recommend for those of you who are new to this topic on InfoQ, a PDF, basically a 100-page summary of the most important parts, or a distilled version, basically, of the actual book. The actual book is still worthwhile reading. I'm totally not saying that, but it's kind of a more verbose version, and it's very storytelling-like, and it might just like, you might get lost in some of the details if you're reading it in the first place. However, the fundamental idea is how do you actually tackle complexity, and that's what the subtitle says, in software development. So Eric basically starts from, okay, we need to build a ubiquitous language that the business people speak and somehow find that language in the first place, and then find means to actually translate this language into the code, right? So basically bring the code and the business together. It's basically, there are two fundamental aspects or parts in the book. The first one is the building blocks of DDD, and that's what we're going to look at, because I think they are very important when it comes to later on to building REST APIs on top of a domain model, the building blocks. And the other part is strategic design, basically how to cope with change, how to evolve your models, how different systems, basically which roles they take when interacting with each other, and stuff like that. All right, so if you've read the book, you probably find this, this graphic familiar. It's basically the building blocks in relation to each other. We're going to look at those four, the entities, repositories, aggregates, and value objects, because not because they are like special within that group here in general, but because they are the ones that are, I think, the most important ones when it comes to how they actually embodied in the code base, and their effect on the way we build the REST APIs on top of them later on, right? So let's start with having a look at how you implement those patterns. I don't want to, briefly discuss what a value object is, but I don't want to go too deeply into that, but rather look into how do these elements actually get implemented in the code base, and what consequences does that have on RESTful APIs. So the first thing, the first building block, the most tiny building block, is actually value objects. So who of you has seen code that looks like this? I call this stringly typed code, right? Everything is a string. You can even extend that type of programming to object-oriented code, which is then every field is just object, right? But what's the problem with that kind of code? Yeah, well, you write methods that look like this, right? They take a first name, they take a last name, they take an email address. And guess what? It's very easy to mix those up, right? Even worse, when someone pipes in a string for the email address, how do you actually know that it is an email address, right? The code that's called, like the implementation of that method, can never be sure, right? You have to rely on someone somewhere having validated that thing. So the idea that Eric brings up is to create so-called value objects. They are basically like typed representations. They make domain concepts explicit. That's a recurring theme we're going to see about in the course of the talk, making things explicit. So by saying, I have a string email address, you completely lose the notion of all the business rules that are surrounded by an email address. So an email address is not an arbitrary string. Right? An email address is an email address is an email address. And you can actually express that by introducing those dedicated types for those primitives. Some people, I try to do that here as well, even go as far as saying there shouldn't be any Java primitives in your domain classes at all. So you even go ahead and do things like first name and last name, what have you. There's certain shades of gray there, I think, but especially I like the email address example very much, because there's like real structure to that string that you can actually validate, and by validating or by enforcing that structure inside the email address class, your domain becomes really expressive, and it actually has real benefits to the code, as we're going to see in a minute. So the problem is that value objects are quite hard not to get right necessarily, but there's a lot of boilerplate to be written in some languages. Read Java, right? You need to create a class with final fields. You need to take a constructor or have a constructor that takes the arguments. You need to implement equals and hash code correctly. All of that crap. Yeah? Other languages like in Scala, you have case classes. They are much more comfortable in doing that. I mean, I just mentioned that because the point I'm trying to get across here is that although that might be considered a bit more effort to implement those types, there's some payoff in the long run, and you're going to see that as a recurring theme in the talk as well. I'd still argue they're worth it in case you want to. I mean, there's like the number one rule of DDD talks is if you talk about value objects, you need to mention Dunn's talk, the power use of value objects. I think it's the most referred to talk that I have, at least in my slide decks. Definitely recommend that. He has basically a 1-hour talk on where he takes some code, like 200 lines of totally undigestible code. It deals with currency exchanges. And then he starts to introduce value objects, only value objects, in that very code. And by all of a sudden, it becomes more testable, it becomes more readable, it becomes simpler. So definitely check out this one. The solution, or one of the solutions that are available in Java to actually not have to write all the boilerplate is a project called Lombok. Has anyone ever heard of Lombok? Okay, a couple of you guys. So for anyone watching the recording later on, you basically use some annotations and an annotation processor. So it's basically a compile time step, in this case with add value, and you have these, like, assuming first name and last name are value types again. You see that value class down there, email address. You just have properties in there, and Lombok basically turns every field into a private final field, creates a constructor, taking all the fields, implements equals and hash code correctly, all the stuff that I just mentioned to be boilerplate, right? Cool stuff. There is auto value from Google. I think it's using interfaces and also some code generation going on behind the scenes. So there are all alternatives. Just the quick thing, value objects, good thing. Don't shy away because of the additional overhead that you might think you need to invest here. Going on to entities and repositories. They usually make up the core of our domain model, the entities, I'd say. So just imagine an arbitrary model here. I'm just pulling bubbles and arrows up to have something to talk about and you relate to. So we have this customer here, has an email address, some payment information, an address. We have invoices that are issued for the customer, so we're sort of building an e-commerce system. There is orders that are placed by the customer, right? So they belong to the customer. The orders have line items, of course, and the line items in turn point to a product, right? So very, very, very standard thing here. And superficially, you might think, okay, what's the deal? And there is a lot of information in that graphic even, or in that model, that becomes very crucial in terms of your domain design. And you might not even see it right now, but even in terms of the API design that's feasible or not feasible to be built on top of that. So the first thing that you should realize is that these bubbles are kind of clustered already. So what we have here implicitly is the concept of an aggregate, right? So that's basically the definition in the book is basically you have a group of entities where one entity, and that's the ones I've underlined here, is sort of controlling business rules and consistency rules over a set of entities, right? So the best example usually is the order over there with the line items here. And the point being that you'd never go ahead and manipulate line items on their own. You'd never just issue an insert or go to the database and say, please go ahead and insert a new line item. But you'd rather go ahead, read the order, programmatically add a new line item, because that process of adding the line item would actually allow you to check certain business rules, right? You'd need to have a minimum total being enforced, right? Or a maximum total. Or you could apply some discounts or something when line items of a certain amount are added and stuff like that. And these business rules can only be guaranteed or assured if you're actually interacting with the aggregate and only with the aggregate root. So there are a couple of things that are important here. Actually, two things. The first thing is an aggregate is sort of the thing that you refer to, you also see that the arrows that I've put in here are always pointing to aggregates, right? They can point from an entity contained in an aggregate, but they always point to aggregates. And the other thing is the scope of consistency. So whenever you change something, the scope of consistency is within the aggregate, right? So if you add 2 line items to an order, they're either added both or none at all. All right. So like, again, looking at that stuff from the implementation point of view, in a, let's say, Spring application or just any other application, the difference between a normal entity and an aggregate is usually that for the aggregate roots, I casually refer to them as aggregate, but actually it's the aggregate root can be identified by an entity plus a repository, right? So going back to that, just briefly to that example here, in the implementation for that project, you probably have an address entity, like classical JPA entity, payment entity, maybe even email entities, because you want to like store them in the database and have multiple ones. But you only interact with those through the customer and the according customer repository. So there won't be a repository for line items, but another one for order, right? And we actually, the point I'm trying to get across is that we actually make a lot of use of exactly that additional information in the code base when we're building Spring Data REST, but more on that later on. An important thing, the aggregates are the scope of consistency. So whenever you, again, as I said, whenever you change something, you'd actually load the entity or the aggregate root from through the repository, access it, and then manipulate it, and also again write it back. Right? So usually transactional scopes transactional scopes are centered around aggregates. In more monolithic applications, you can often see manipulations of aggregates, of multiple aggregates, even within one transaction. But if you're moving to more of a system of systems, basically, that consistency rule will actually be a very strong one here. And I get back to that in a second when it comes to bounded contexts. Another thing, another aspect that I mentioned is that you only refer to aggregates, right? You never refer to any entity that's not an aggregate root. And that becomes, that fact or that rule sort of becomes quite important again when it comes to the building of REST APIs on top of that. So one thing I'd like to spend a minute on as well is that sometimes people get too stored in database thinking, and they're thinking like of their model as being something that's like written to the database in the first place. So it's not that the persistence aspect is a consequence of we're using a database, but we have this database and now we have to extract a model from that, right? And actually extracting, let's say, JPA entities or something from a database is sort of one of the most wrong things you can do in the first place. And why is that? If you look at this thing and imagine it's mapping on a database, right? Then you probably, like, you're all familiar with relational databases, I guess. The relationship between the line item and the order is what? Yeah, it's a foreign key, basically, right? I don't even care about it, whether it's to many or to one. It's a foreign key, right? The relationship between the order and the customer is what? A foreign key, right? So if you look at the way that this thing is represented in the database, there's absolutely no difference in the relationship between order and line item and order and customer. However, in the model, in that model that I made up here, there is, right? So I modeled these things as aggregates, and there's definitely different relationships between the two. And if you just extract your domain model, or try to extract your domain model, because I'd argue if you do pull stuff out of your database only, you're not going to end up with a domain model, but just a giant sea of entities. And that per se is not really bad, but most people just like skip the necessary step of then looking at all that stuff and finding where are the aggregates and actually changing or tweaking the code accordingly. All right. So another quite important aspect in from the DDD book is the concept of a bounded context. The graphic I have here is a very entity-driven way of representing our model here. So we basically model our entities. But just think about the order, right? If you're talking to a person that's working in the shipment or in the shipping department, when that person speaks of an order, it's interested in a lot of way different things than if you, let's say, speak to someone in the department that's then responsible for invoices later on, right? So while the shipment department is only interested in like the actual shipping address and doesn't really care about the amount, right? It might be interested in the total of or the number of line items, because by that the shipment costs may be rising. But it's totally not interested in what the stuff in there actually costs. Whereas the invoice department or the billing department couldn't even care less where that order is going to be shipped to, but rather how much does that bloody thing actually cost, right? So the bounded context is basically is a concept from the book that sort of defines, okay, there are these areas or these contexts actually in which a term from the domain has a certain meaning and has a canonical meaning, right? So you're rather centering or trying to find these boundaries and try to build up your system or split up your system into these bounded contexts, so that whenever you speak of an order, that particular concept actually makes sense to the persons involved in that bounded context, right? So that's basically what you usually end up with. An important aspect here, and that will get important later on, is that usually leads to the fact that the customer is not something canonical anymore, but it's something that's like sort of spread around the code base, right? So, and what I try to make obvious here is that there's always one system that basically defines the identity of the customer. So whenever you have used an e-commerce system recently and registered with that system, you usually get like guided through a series of steps in registration. So you start putting in your name and your email address, maybe in the first place. So that's basically the user registration. By that, you're becoming a customer with an identity, usually a user ID or something. And then in separate other steps, you add your billing information, you add your shipping addresses and whatnot. And if you're looking closely at some of the shops, just like if you look at Amazon or something, you can even realize that when you're editing this information, you're not even talking to the same system depending on what information you're editing, right? So if you edit your payment information, look closely, the URI changes quite significantly. They all just happen to look the same, so that to the customer or to the user, it basically looks like the very same system. But effectively, let's say the payment information that I'm adding is just only available in the payment or in the accounting system. And these systems all refer to the one customer, to the canonical thing, through that thing that is actually defining the identity in the first place, right? So it's usually, in a REST world, it's usually a URI, right? So the same thing applies to the catalog and, and the references to those in the orders, right? That might also lead to even data to be duplicated. Let's say for an order, you might want to copy over some information of the product that you've ordered, just for the very fact that, like, let's say there's some description in the order there, I want to in the product, and I want to copy those into the orders because I don't necessarily want the order to change when the product description changes. So there's some data duplication going on even, right? All right. The final thing on the DDD side and basically on the foundation is the topic of domain events. The first mature, like if we're talking about it in terms of a maturity level, the first thing or the first level basically is that your application code doesn't have any domain events at all, right? So you basically have classes that have getters and setters, and all you do is you poke at those getters and setters, and by that sort of change the state of the application, and you actually just change data, right? So the second thing is that you can, instead of just poking at the data, you could go ahead and make operations explicit. There is this quote from, I think Von Vernon was it who coined it in the first place. Whenever you're like calling two setters in a row, you're actually missing a concept, right? So you're doing something to that entity, and you're doing it in some context, and you're not making that explicit, right? So you basically, it's usually then refactored into a separate method where you then call these two setters. But why not make this an explicit operation on the entity, right? So instead of set address, call it and make it a move, right? The customer moves from address to A to B. That should be an explicit operation. The next thing that you can actually do is, additionally to the state changes that you apply to your entities, you can make sure that you capture important operations important to your business as events in some case, right? That might just like mean that that you just like persist an additional object to your database, an event object that basically says, okay, this order was created at yada yada yada. Right, so make those things explicit, because then you can later on query those events, query your database for those events. Right. The extreme version of that is, so that's what I'm trying to get to. Important domain events should become like state transitions, and that actually already maps to the REST world to some degree. I go back and come back to that in a second, really. Yeah, okay, let's skip that one. Or not skip, but move that to later on. The third aspect is, or the last aspect, Jesus, that thing is a bit quick here today. The extreme form of this kind of event handling is called event sourcing or CQRS, where you basically change the way your application works entirely by only storing the events that happen to the system, and then having a read model that basically replays the events and then gives you the state of the system, so you basically reallocate that. But that's usually, it might be a step too far for some of the systems that are already existing. The point I'm trying to get across here, it's basically a maturity level for explicitness of domain events, right? So we might bury those in just poking at data. We might make them explicit. We might keep those as events, or we might just like model our entire applications around that. All right, but I get back to that in a second. So what about the REST aspect? The first thing that I'm trying to, or that we have to discuss, is that I talk to a lot of people that just basically think that what a REST API is, well, we take our entities, we just like turn them into JSON, right? So we flip the relational tables that we have, we flip them by 90 degrees, call that thing JSON, and then throw that out to the public. and then just say, okay, get to access things, post to create things, put to update things, and delete for removing them. The thing is that might work for some cases, and it might work for simple cases. That, however, doesn't mean that you can or even should try to solve all of your, or expose all of your domain logic like that. Fundamentally, this is mapping back to the domain events level 0, right? We treat everything as data that we can just like poke at and change, right? There's no business operations becoming explicit. The client doesn't really, or has to somehow all of a sudden know when it's allowed to do what. And yeah, that's kind of a very generic approach here, but it comes with a variety of downsides, and we're going to see a couple of more of them in a bit. The other problem with that, okay, we're exposing our database to the web, is that that's not going to work really, because if you take the approach of you have just like a one-to-one mapping between your entities and your database tables. You don't think about aggregates at all. And that's basically what usually those reverse engineering tools actually generate. You get to a point where the entity could be related to another entity, which could be related to another entity and yet another entity. And when you then go ahead and you take that, or you create that Spring MVC endpoint saying /customer/4711, and you take that customer instance, read that from your database, and then go to Jackson and say, serialize that thing for me. And Jackson just like looks at the getters and says, oh, there's this other entity, and there's this other entity, and there's this other entity. And you end up with like a megabyte of JSON with half the database basically pulled into the web, because everything's sort of connected to everything. If you're lucky enough, then you have just like some circular dependencies, or that thing goes boom, right? So the problem here is that we actually need to think about what the representation of our resources have to look like, or should look like. I'm quite a hypermedia aficionado. I couldn't even care less about what the URI actually looks like, but ironically, that's what most people start to think about when they're building APIs these days. But no, the question is, when I have a resource for a customer, completely independent of what the URI looks, what do I actually want to include, and for whom, and who actually gets control over that design? How can someone maybe include more properties or less properties, what have you? So that's a very, very, very important question here. And guess what? By moving away from just looking at the raw data and more looking at the model, you can actually find great guidelines on how to actually structure the representations. We see a bit of that. So picking back up on the DDD part here, let's start with value objects. Not only are they a bit a pain in the ass to actually write them, they also then again on the representation side of things need a lot of custom serializers. That's a bit of an issue with, let's say if you're working with Jackson. There is a bit of support, just a sidetrack and to segue into the talk on Spring Data REST. We have some code that sort of allows you to just declare this object here is a value object, and then we will allow you to just define the way that it's supposed to be in to look in the JSON. So basically, customize Jackson for you so that you just say, hey, this is a value object, and then Jackson does the right thing. However, again, a bit more effort, which might let you shy away from using them. Don't do it. Value objects are great. The other thing is that, okay, here are these are the like three, or actually, if you look at it more precisely, it's actually two in here. Two aspects of aggregates that are nicely mapping into the way we want to build RESTful APIs. So aggregates are identifiable, and by that they are actually referable. That's why the first two aspects can actually be one. and they are the scope of consistency, which actually maps nicely onto REST resources, right? REST resources are identifiable because they have a URI, and they are the scope, or they are a nice means to implement scopes of consistency, basically, because if that resource is the scope of consistency, I can actually issue a put request and be done with it, right? So as soon as I have to sort of interact with multiple resources, let's say 2 or 3 resources at once, and want to create something as a whole, right? Then the question comes up, okay, I mean, the first 2 requests actually worked, the third didn't work anymore. How do I actually like roll back the other 2? I'm not saying that this is like generally bad. It just requires way more effort. And if you can like get to model your resources that they support this pattern, and they allow you to just like or let the clients basically send some data and then create even a more complex resource in the first place with just one call, that has a lot of benefits here, because like all the other things are not going to matter then. All right, so one thing that, and I think that I accidentally deleted a slide here, there's supposed to be a hypermedia slide in the between the 2, just like saying hypermedia. And what is hypermedia all about, and how does that actually help in terms of like building good RESTful APIs? Well, actually, it doesn't really even help building good RESTful APIs, because actually an API that's not using hypermedia is not a REST API. The fundamental idea is that we're not only serving data, so not only take the table and like flip that by 90 degrees, throw that at the client, but we also tell the client or send the client information that it can use to actually do something with the data. It can find out what to do next, basically, with that thing. And that's where the HATEOS, hypermedia as the engine of application state, comes in, because a hypermedia-driven client would go ahead, like inspect the hypermedia elements and then act accordingly. And that's basically the mechanism of how you like, yeah, basically do that. That's it. How do you implement hypermedia? Exactly that way. But what does that mean? So assuming we have these 2 options, right? We send just like plain JSON to the client, or we send JSON and some links to the client. Doesn't that make the client more complex? That's a question we might have to answer. And the other question, what benefits do I actually get from doing that? Why would I want to do that in the first place, right? So what we're basically doing by that, and I'd like to go into a bit more detail of that, because it's a pretty important point here, is that we're trading 2 different complexities with each other, basically, right? So on the one hand, we have domain complexity, business rules, and stuff like that. And on the other hand, we have protocol complexity, or that's what I call it. It's basically the client having to understand, this is not only JSON, but a special kind of JSON that has links in them, and those links are telling me something, and I have to understand these links, right? So that's the protocol complexity. It's got nothing to do with your domain. So let's say you have a non-hypermedia-based system, so the simple, just like throwing JSON at the client and the client doing something with it. That means the amount of domain knowledge is very high in the client, right? So the client has to know URI structures. It has to know where to do the calls, right? Not only a single URI, but basically every URI that's available on the server-side system. It also has to know about the semantics of the field. So it not only has to know that there is a field, let's say for a system where you take orders. It doesn't only have to know there is an order status in the JSON, and I can just display that. It also has to interpret the status by looking at the value and then saying, okay, if the status is X, then do Y, right? So it has domain knowledge, very, very fundamental domain knowledge. It doesn't have a lot of protocol complexity. It just has to know JSON. That's basically it, right? And that basically leads to the fact that there's a strong coupling to the server, meaning that whenever those business rules change, let's say the status of with the status of the order, when can I actually pay the order, right? In a certain status only. So let's say on the left side of that field here, the client would inspect that status field and then display a button saying checkout, right? So if you now go ahead and move away from putting all that domain knowledge into the client and rather move to the other side, so teach the client more protocol knowledge, and by that be able to remove the domain knowledge, or a lot of the domain knowledge, then you can lower the coupling between the two systems. And why is that important? I mean, what is actually causing that? I mean, the issue here being, why do we want low coupling in the first place? Let's say if you have a microservices-based system, everyone is building microservices these days, right? You have a server system, and they have 4 clients maybe, and you want to change something to the API, in the API. You want to implement a change, and you want to deploy that change, right? And it's a breaking change, right? So then you have to redeploy all the 4 clients as well. And you basically create a coupling between the systems in terms of deployment. And if you change those systems again, you have another set of clients, yada, 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 and you basically get to a distributed monolith because you have to either orchestrate the deployments, or you have to create new versions, what people call versions of APIs, which usually are just new APIs, to work around that, right? So you create some kind of effort, you create the need for communication between the teams, which is actually something that you want to avoid with microservices, right? So you just want to deploy new versions of your software like continuously, and if you can decrease the coupling between the system, that's actually a good thing here, right? So yeah, one thing here is that you want to be able to change the APIs or involve them if you have a system of systems, basically. Let me give you a quick example here. Again, this is that I just mentioned. You have the order, right? It has a status field, payment expected, and the client is not. Let's say we stay on the left side of the spectrum that I just made up, and we're not only like treating that thing as data, but we're not only treating that as data, but also inspect the field for the decision whether we want to actually when we actually display the checkout button. Then we go ahead and inspect that field, right? So there's nothing wrong with that, except for when business on the server side now all of a sudden decides we have a new requirement, right? So all user-facing text should be internationalized, and that basically means, damn it, if we implement that, we break all our clients. And that's a bad thing, right? So what could be the solution to just that? Yeah, well, let the client not actually use the status field for that decision, but just look at the links that you put into the representation. Let's say you have a payment link there, or in this case a cancel link, and only let the client go ahead and basically say, whenever that cancel link is present in the representation, I build a I show the cancel order button, or I show the checkout button, or what have you. And it's not really touching all the other data, but only making use of it for displaying purposes. What we're actually doing here is we're reducing, and that was the task of the exercise, we're reducing the domain knowledge of the client and moving it to more protocol knowledge. And basically, we're able to sort of change we keep all the complexity of a business rule on the client, and the only thing that a client has to do is basically, is the link there, is the link not there, right? Right. So the thing is, what has this stuff to do with DDD? You might ask, right? The thing is that by doing that, we're actually doing something that's a core aspect of DDD, which is making things explicit, right? You're not like sending a JSON and then you have a status in there, and then the client basically decides when to display the button based on that data that is in there. But there is an explicit link in there that basically tells the client, now you are allowed to actually check out, or now you're not. A very interesting or very important topic in that area is security, right? Just imagine the client having to find out whether it's allowed to actually do things, or let's say display a cancel order button. Maybe only users with certain privileges are allowed to do that, right? In a non-hypermedia based system, a client has to go ahead and then see, okay, there is this cancel order functionality, and now I have this user account, and now I have to somehow go ahead and check whether the user has some permissions, again with a server call to the API, and if that returns true, then I can actually display the button. None of this is necessary if you just like go the hypermedia route, because if the client just says, on behalf of that user, show me the order, and the server basically detects, oh, this is user X, he's not allowed to actually cancel that order, I just don't send the link, right? That doesn't mean the server doesn't have to check that the server might not, the client might not issue that request in the first place. But again, the client is completely free of, in this case, not completely free, but it doesn't have to actually bother with whether is this action allowed or is this action not allowed at all. Right, so that's a fundamental thing that actually, at the point in time when I realized this, when I started putting these state transitions into my representations, or these links to trigger these state transitions, you really start to see, okay, there's this connection between, okay, this is this important domain event that I want to or have to basically expose to my clients, let my clients trigger that domain event, and I need to make that explicit, right? I don't want the client to just like patch or issue patch requests to my resources, but I want to offer it guidance to actually do things, right? I'll be coming back to that in a second. Another aspect in the general procedure is one that, for a lot of things, technological things that might not be obvious in the first place, that you use on the back end when you just write server code, right? So basically, you have your entities, you have your repositories, you have your services. You just interact with them, and just invoke operations on them, store them back to the database, yada yada yada. There are a couple of implicit technical concepts that we all got so used to that we might just not think about them when we throw or try to create a REST API on top of those. And one of them is the first thing, or the point I'm trying to get across is that you should be aware of those, and you should make sure that you actually translate the concepts for which HTTP has a solution for into actually that solution, right? So the first thing is that, that's more of a pattern here, but what we're actually doing with, let's say, Spring Data REST, or what people do when they just implement REST resources using Spring MVC, they usually use this collection resource, item resource pattern. So you have a resource that serves all of the customers, and you have a resource that serves individual customers, right? That maps nicely onto our Spring Data repository pattern. So in the repository, you usually have methods to either access all of the entities or paginate through them, yada, yada, yada. A very important thing in Spring Data REST basically is, and if you're interested in to learn more about it, I encourage you to come to the talk on Thursday, is that we can actually look at the relationships between the entities and the aggregate roots. And in the representation design, we can cut off the places where you actually point to another aggregate, right? Remember that order line item customer example right? So we have the orders with the line items embedded, and the customer being something separate again. So we have different kinds of relationships, right? And it's a good idea to just go ahead and say, okay, within that aggregate, I just include everything in my representation. So when I look up the order, I basically get the order, some order information, and then all line items nested in a JSON structure. But as the customer is a separate aggregate, right? It has a separate consistency, a separate life cycle. We actually shouldn't include it, because that, when we issue a put request to the order, would raise the question, okay, we're now manipulating two aggregates at once. Is that what we really want? I mean, conceptually, if you have an order and the customer is embedded, and let's say you get a request that changes the customer's name, like when you update the order, is that really does that make sense even, right? Do you want to change the customer's name when you update the order? I guess not, right? So it's more, the customer is a related thing, so use the concept that the web actually exposes for pointing to things, which is links, right? So instead of embedding the customer, you'd go ahead and have a link saying, by the way, the customer lives over there. One of my favorites. Usually entities, by the virtue of the fact that they're persisted to the database, carry an artificial property, the identifier property, right? However, if you really think about it, an ID is not really a domain concept, right? If you're a customer at a shop, you probably in their IT systems have an ID, but first of all, you're just a customer. And the issue with that is that, if I've seen a couple of sys or technologies that when they expose or try the same thing basically as we do with Spring Data REST, they expose the identifier property to, or put that into the JSON document. And I think this is fundamentally wrong, because HTTP just has a concept of identifying things, right? URIs, unique resource identifier. It basically says this is the thing that identifies customer with the customer, which in our backend system may be the customer 4711, but on the protocol level, the ID 4711 doesn't really do anything. We need a URI, right? And the problem with exposing the IDs in the body is basically that you create ambiguity, right? So if I issue a put request to customer 4711 that contains an ID with 4712, what am I supposed to do as a server? Do I actually change the ID of 4711 to 4712? No. So having multiple IDs or identification schemes flying around is usually a bit of a brittle thing, and avoid that. So that's why, let's say, Spring Data REST, for example, basically removes that property from the representation, because for the client, that property shouldn't actually matter at all. It has to refer to things through the URIs, right? The same applies to optimistic locking and diversion properties. HTTP has a concept for that. That's an E tag, right? So it's basically a hash over the representation, a hash over the state. So for all the aggregates, the adversion annotation or the adversion version field can or should be translated into an E tag. Again, this is what Spring Data REST does out of the box for you. But even when you're just hand coding that stuff, that's definitely a thing to, or would be a thing to do here. A good thing to do. And the same applies to last modified properties. Why is that a good idea in the first place, to expose those properties as headers? Because it allows certain mechanisms of HTTP to just work out of the box, right? I guess you've heard of conditional requests. So with a GET request, you can, for example, say, if non-match, set a header with if non-match with, let's say, an E tag, which basically expresses, dear server, only give me the customer in case it's not matching the E tag. Here's the hash, right? So, and that the server can actually then use and say, okay, this thing hasn't changed at all. I don't need to waste any bandwidth to send you that stuff. So you can by translating those concepts into the HTTP appropriate ones, you can actually make sure the infrastructure can use these concepts. All right. So rounding things off, there is a sample project that I started quite a while ago that sort of implements all of the stuff that I've just mentioned. Like I try to use value objects throughout the code base. So try to be a good DDD citizen here. But even more importantly, and then show you how to build a nice RESTful API that also does all the things that I just described on top of it. It's basically the sample is the sample as a concept is taken from a book called what is it? RESTful Web Services with O'Reilly from Ian Weber. Ian Robinson, Jim Weber, and Savas Parastadidis. I probably totally wrecked his last name. And it has a strong focus on hypermedia, so highly recommended read. It basically is modeling a Starbucks coffee ordering experience as a REST web service. I like it quite a bit because it has, in my mind, it has the right balance between being a very simple and understandable sample, but at the same time having quite a few interesting aspects of RESTful APIs that some very simplistic examples usually don't have. Some of them being, that's basically the state chart of the order that processes through the system. So you basically place the order. It's in the payment expected state then, in which you can update it, right? You can then pay it. That's the step 4. You could cancel the order while it's in payment expected state. While it's preparing, it's basically issuing a server-side, some long-running thread. It's basically a thread sleep of 20 seconds, so pretty close to what Starbucks employees usually do. It's then ready at some point, and then there's another request that you have to issue to complete that thing. And it raises if you just model that thing naively and the way that usually these API development tools work, it's you wonder or you think about the URIs in the first place, right? This is important. No, it's not really. So you basically get away from that here, and the problem being you hard code these URI patterns into the client, they might change. You cannot really implement. How do you actually implement that, or how do you actually guide the client that it can only issue the delete request to cancel the order if it's in payment expected state, right? That's something the client has to do. It creates incentive to do exactly the wrong thing, right? Baking, hard coding URIs and inspecting the payloads to make business decisions, right? If you go ahead, move away from that and rather say, okay, I make this entire thing link-based or hypermedia-based, I basically go ahead, we introduce state transitions so that it basically becomes explicit when a certain transition is allowed, right? We just introduce link names there, and then that sort of, if you just document that, no client would ever, or no client developer would ever get the idea to try to interpret some of the payload, except looking at the links and saying, okay, when I found this cancel link, I can issue, let's say, a delete request to that resource that is linked to, yada, 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 right? So there's a Spring implementation, as I said, that is built on Spring Data REST, and also there's a bit of manual implementation code that just shows that Spring Data REST is quite extensible. If you want to see more of that, in my please come to my talk on that topic on Thursday. Maybe one aspect that I'd like to get across here. So far, I spoke about, or the primary aspect of all of that hypermedia dance being to lower the coupling between the server and the client so that we can get a bit of lag room in the server-side implementation to change things, right? And Another aspect that actually comes in quite handy often is that with that style of API integration or implementation, you can, in some cases, even get the client to pick up functionality that it wasn't even expecting in the first place. Let me give you an example of that. Let's go back to that thing. Oh, Jesus, that was too far. Let's go back to that thing here. The state diagram, state chart basically says we can only cancel the order if it's in payment expected state, right? That's kind of unusual. That's not really how Starbucks work. If you don't like your drink, or you're just somehow unsatisfied, or you're just not accepting it, you can still cancel it later on, right? So if you implement the client in a way that it says, if the cancel link is present, I display the cancel order button to actually cancel the order, then business could even go ahead and later on say, well, or the server side could actually go ahead and say, well, so far we only displayed the cancel link in that particular state, payment expected, but why not just like sending out that link, adding that link also later on, right? While it's in preparation. Also, even if the drink has already been prepared. And you can just like add a new link on the server side, and if the client is built in a proper way, it would just actually just like be able to cancel the orders later on, right? Even if it wasn't designed with that in mind in the first place. So you get you basically move all of the business logic, you keep the business logic more on the server, and that usually is a good thing. Because, I mean, yeah, you just like have to, otherwise you have to re-implement that logic both on the server and on the client, which just creates that strong coupling. Just like a couple of pointers in case you're looking at, you decide not to come to the session on Thursday and want to look at the sample as well. Something we often get criticized for is that, like with the Spring Data REST implementation, is that people say, okay, well, what I don't like about that is you take the domain classes, the entities, and you turn them into JSON, so there's a strong coupling like between like the API and the domain model. And I say, yes, there is, because what's the point of like not doing it, right? If there's a first name property, you might want to expose the first name property. Plus, you can like tweak the mapping through the mapping library, right? There's Jackson in place. You can like register mixins, you can register custom serializers, and they would all be just like realized. Just imagine us publishing a framework where for every entity you have to create a domain class with the exact same properties. Would that, I mean, we probably would have been gotten bashed much worse for that. So there is a mapping step. That's what I'm trying to get across here, and there should be. So I think it's totally fine to start with sort of the structure that you have in your domain model, because I mean if it's the core of your domain, well, yeah, I hardly get the argument here. However, if there's important bits. You need to take care of thinking about the representation design, and in case you want to tweak things, use the mapping library capabilities of that. There's a dedicated class called Jackson Customizations in that example that has all of the Jackson customizations. There are a couple of them in there, like for dates and for, I think, quantities and stuff like that. Yeah. Also an important part, I get to that in the other talk in much more detail. Don't try to overuse, like let's say in this case, Spring Data REST. If it doesn't like work because of like the business logic is too complex and you don't that CRUD model doesn't really fit, don't try to make your domain model or your operations to fit the CRUD model, and also don't try to bend Spring Data REST. There's like a couple of connection points where you can just like go ahead, implement your own Spring MVC controller for just that part of the functionality, and then integrate that with all the API that Spring Data REST actually exposes. Right? Yeah, the resource processor interface. There's a couple of them. It's an SPI interface where you basically can tweak the links, and that's the primary places to look at if you want to see how these links are basically put into the into the representation. But yeah, all right. So there's a couple of resources. There's the project in my GitHub account. I sort of wrote down the 5-minute elevator pitch for hypermedia and the consequence of API evolvability in a blog post. So if you want to share that with colleagues, there's that. And that leaves me 5 minutes for questions, if there are any. Go ahead.
So you should go, I think it's 7 or 8 slides back to show the RESTBucks state transition.
Mm-hmm.
Because we currently hardly depend on rank sourcing for REST.
Mm-hmm.
We are fighting pretty hard on how to map those command state changes. Right. Right. So you have currently you see here there are at least 4 different types of staging, right? And the upper 3 preparing, ready, completed.
Yeah.
How would you map them to a REST API interface?
Well, I mean, so the question is, there's like he was talking about a CQRS-based system, and how would these state transitions map to these CQRS commands then? Like, wouldn't a state transition be a command to the
The point is that our current point is that we are, you have your resources, right? So let's talk about pretty simply, you have the order, in this case the order,
Yeah.
payment, and you say, okay, I'm payment expected, and now I'm going to go to the next step by preparing it.
Mm-hmm.
So you could make a patch or a put with any command information,
Mm-hmm.
right? That is the next step would be ready.
Mm-hmm.
So okay, then once again, call a put or patch on it.
Mm-hmm.
And if we don't want to rely on having the business logic of the take over there into the client, so we could do 2 things, right? So
Oh, okay. I think I see what you're heading for. So the question is, if you treat these things individually as a command, right? How do you actually like then put the state back into the into the representation? So the example doesn't have that implemented as CQRS system, but just like as an ordinary just like implementing. It's basically on the first level only of the event maturity model that I made up. So we basically just have operations on the entities, and actually there is like for these not all of these steps actually refer to individual resources. So there's still the order resource, and the order resource is basically inspecting the state, and that's basically then getting back to your read model, sort of inspecting the state, and then adding those links. So of course the server implementation has to look at the fields and say at the status basically, right? But this is okay because that's the server process and it's self-contained. So it's basically deciding when that order status field of the order is there, then I put in the link into the representation. It's just that I want to avoid exactly that logic to be duplicated on the client. That's the whole point actually. And I think you should be able to just copy that approach to a CQRS-based system because all we're doing is basically take the current state of the order and basically translate that into a representation. And by that, in that step, we actually add links based on the state of that thing. And I mean, you have this probably this short consistency gap here. But even if the client, let's say that state doesn't really propagate immediately to the read model, then the client would just see for a tiny second for one request, it wouldn't see any other links, so it would just not do anything to it, and then maybe just refresh a moment later and then get the correct state again. So that's kind of one question.
I also have a question about the client side.
Yeah.
When I'm thinking about a human presentation, that makes sense, I guess.
Mm-hmm.
I can use an XSLT process or something that will just take my response and transform it to a web page.
Yeah.
With those buttons drawn, it's really easy.
Mm-hmm.
But if I have a system-to-system integration,
Mm-hmm.
should I have some sort of object, like a Java object representing behavior available to the system? So would you expect in this case, I will return an aggregate analog for the client, which will have methods like is payable, is cancelable, and
Yeah,
then
yeah.
cancel.
So the question is like that all of that stuff seems to make sense for human-to-machine interaction, which is quite obvious because most of that stuff is basically derived from how the web works, right? But does that really work for machine-to-machine communication? And the second question was, should we have like the concept of or an implementation of the very same aggregate on the client? So actually, for the first question, I'd argue it shouldn't actually make too much difference whether it's like it's a human being. I mean, when we browse to Amazon, to the website, we look at the link name and then we pull out semantics from that. For machine-to-machine communication, you of course have to find means to define the semantics of what does the payment link actually mean, right? That can be documented, that can be even like machine consumable. You might want to, I mean, you can take that to the extreme, of course, but I'd argue that the fundamental benefits of in terms of reducing the coupling are already given if you just like, even if you hard code that knowledge into the client, that hypermedia approach already gives you a lot on that path. So I think that still makes sense. The other thing is that you can of course go ahead and basically like on the client, I mean, let me start the other way around first. As I said, we're moving to more protocol complexity on the client, where I see a lot of room for improvements in terms of supporting libraries and stuff like that. There already are libraries around that support a lot of hypermedia-based media types like HAL, collection, JSON, Siren. We're also doing a lot of stuff there in SpringOne. There's quite a big change coming with a prototype for more affordances. For other media types and an affordances model. When it comes to the representation of the domain of the aggregate, you of course can do that because it just like might make the implementation of the other client code easier, right? If you can just like have code that you say is cancelable. The crucial thing I'd say is that you then for the implementation of those is cancelable methods, you'd have to resort on the presence of the links. So I mean, I can imagine that's somehow like you could make this generic in terms of like is payment or is payable or something, and then just inspect whether there's a link relation of the same name. But you basically have to go ahead and use the means that the protocol basically gives you there. Yeah, but that's it. All right, one more maybe? Is that okay? Let's take one more question. I take the other ones offline if that's okay. Go you in.
I have a question also regarding state transition.
Mm-hmm. Mm-hmm. Yeah. Can you repeat the last part, the last sentence? How would you?
Under given a situation where we remove the IDs from the resource.
Yes. Yeah.
How would we reference a single entity if we have a collection of resources in order to iterate?
Oh, okay. So the question is, if we remove the IDs from the representation, like the backend IDs, how do you actually refer to the, let's say you have an embedded collection of other entities, right? How do you actually refer to the individual instances? And that's a good point, and that's a crucial point, as usually the most media types that fly around, like JSON probably being the most prominent one, they rely on the order of the items. So when you say you have line items and you have 10 in there, you just rely on the fact that the first item is the first item, and that just like maps to the server side thing. Of course, you can sort of loosen that constraint a bit when it comes to embedded documents. Because I think the problem of like having multiple IDs, or the case of the ambiguity, right, between the ID that's in the document and the URI is not even given for nested documents. So it's not so much of a problem. So just you might want to keep them in there. But as a default, I was kind of thinking, okay, or saying that don't try to transport other forms of identification like out of your system, right? Because in general, that you're using a long as auto-incremented long in the database the client shouldn't even bother, right? Why does it have to know in the first place? Yeah, that's the issue. Okay, so thanks for taking the time. Would be glad to see some of you back on Thursday, but for now, enjoy the rest of the day and the conference in general. Thank you.